All right. So if you would please find your textbooks and we're going to turn to page 104. All right, so on page 104, we're going to take a look at more proportional relationships, but this time we're going to look at it in a graph and in a table. Okay, and so one species of bamboo can grow on average at a rate of 60 centimeters per day. Okay, so in one day, I'm going to grow 60 centimeters. Complete the table of values using the given growth rate of the bamboo plant, then complete the graph. All right, so let's just stop and think about this for a second. All right, so if I have 0 days, 1 day, 2, 3, 4, actually, let me go back and change this. Let's look at this right here. I should have looked down here. Okay, let's go up by 3. So 3, 6, 9, 12, and 15. Okay, let's use our numbers that we already have. But let's take a look. So at 0 days, do you think my plant has grown any? No, we're going to assume that we just planted my plant on day 0 and it has not grown at all. Okay. After 3 days, I want to know how high my bamboo is. Well, if 1 day it is going to equal 60 centimeters, if I've grown for 3 days, how tall am I? Okay, so if I'm going from 1 to 60, I need to go from 3 to something. Well, 1 to 3 is times 3. So all I got to do is just 60 times 3. So 60 times 3 is 180. All right. So if I now have grown 6 days instead of 3, I'm just going to do 6 times 60 because I'm going to multiply the number of days I have by 60 because I know for 1 day it's 60. And if I'm now growing for 12 days here, I'm at 720, or 15 days, I'm at 900 centimeters. Okay. Then it's asked to use my table and to graph what I have. Okay. So I have 0, 0. Unless you are told your X column is always first and then your Y when you're looking at a table. Okay. Unless you are told otherwise. So now I can turn these into coordinate points. Well, I have 0, 0, 380, 6, 360, 9, 540, 12, 720, and then 15, 900. Okay. Just to give us a quick little refresher and recap, when we plot points on a coordinate grid, we always start with X first, which is our horizontal axis, and then we plot our Y. Okay, we start with X and then we move to Y. So our first one is 0, 0. Well, I start here at the origin and I actually don't go anywhere. Okay, now let's take a notice. I go up by 200s each time, which means each individual tick is 100. All right, so let's go ahead and graph 3 and 180. So I go to 3. I don't go to 200. I'm just going to go just below 200. And I'm going to get a good guesstimation if that's 180. Now I have 6 and 360. So 6, I'm going to go up to 300, really close to 400, and I'm going to plot a dot right there at 360. Okay. The next thing I'm going to look at is that I'm going to look to see where is the next 100, because in order to draw a straight line, I like to find where these go here. So I see that I have 15 and 900. Well, at 15 days, I have grown 900 centimeters. Okay. And then let me add this extra point here. If I have grown for 30 days, how far or how tall have I grown? So 30 times 60 is 1,800. And that's going to plot me right here at 1,800. Okay. Now I'm going to go and find a straight edge. So if you guys have a ruler, that can be very handy dandy. If not, then I learned this last year, that if you take your paper, you can fold it in and you can get it right to where it needs to be. So then now you have a straight edge, and then just follow your paper straight up. Okay, I got a little off there. Okay. Number 10, describe how the time affects the height of the bamboo plant. Okay, so we can see here that as the time increases, the height of my bamboo is increasing. Okay, so as my days increase by 1, the height of my bamboo increases by 60 centimeters. As my days increase by 1, the height of my bamboo will increase by 60 centimeters. Okay. Is the number of days of growth proportional to the height of the bamboo plant? And explain your reasoning. All right, so there are 2 things that tell you this. The graph and your constant of proportionality, your K value. Okay, so the answer to this is yes. Is it proportional? So the first thing is our graph. So my graph supports this. Okay, and my constant of proportionality, my K value. All right. All right. We have a new term to learn, and that's called direct variation. Okay. So you saw that the height of the bamboo plant, it varies based on the number of days the bamboo grows. For example, for each increase of 1 day, the bamboo grows 6 centimeters. A situation represents direct variation. There we go, direct variation. If the ratio between the y value and its corresponding x value is constant for every point. If 2 quantities vary directly, the points on the graph form a straight line and pass through the origin. So straight line, pass through origin. Okay, that's super important. All right, and here's another example of that. Okay, so a car driving at a constant rate of 60 miles per hour is an example of direct variation. The distance traveled varies directly with time. A sketch of a graph that could represent this situation is shown. So they just gave me a quick sketch of distance over time. As time increases, distance is increasing. When you sketch a graph, be sure to include the labels for each axis. However, you don't always have to show your values. All right. So number 1, explain how the situation in the worked example is an example of direct variation. Well, it's the same thing as my bamboo. As my time increases, so as time increases by 1 hour, because I learned that up here, so 1 hour, 60 miles. So as my time increases by 1 hour, the distance traveled increases by 60 miles. Okay, the distance traveled increases by 60 miles. Explain how you can use each graph in the previous activity to determine if it's proportional or not, to determine which scenarios represent direct variation. Okay, so direct variation deals with proportional graphs. All right, and that's where our statement of direct variation comes into play. Okay, to be direct variation or to varies directly, it needs to be a straight line and pass through the origin. So I like to say there are 3 rules that you need to have in order to be proportional and have direct variation. And the first one is to have a straight line. Okay. My second one is to pass through 0, 0, or it's also known as the origin. Okay. And the last one, my third, the third one does the first two, okay, is it has a constant rate of change. Okay, is a constant rate of change. All right. So knowing these three, can we list another example of quantities that vary directly? Then sketch a graph that could represent the relationship between two quantities. There are many different answers that you guys can come up with as long as it has a constant rate of change and it starts at 0, 0. So you want your graph to look like this. All right. One of the examples I came up with is that if you can go to the store, you can get 2 apples for $1. Okay, so if you think about it, if I have $0, do you think I can get any apples? Well, the answer should be no. So for $1, how many apples can I get? And I can get 2. Okay, so 2 apples for $1. So as the dollars increase, the number of apples I can get increases here. Okay, talk the talk. All right, how are all the graphs that display proportional relationships the same? Okay, well, we just answered this. As long as they are in a straight line, pass through 0, 0, and they have a constant rate of change, they will all be proportional. Okay, so sketch a graph that displays a proportional relationship. Well, we just did this. Okay, I have my y-axis and my x-axis. And there we go. A line that is passing straight through the origin, and that is a straight line. All right, and then number 3. Which table displays linear relationship and which display proportional relationships, and explain your reasoning. So let's find the proportional relationships. Okay, in order to do this with the table, you can create what we like to call a K column. Okay, we learned the other day that K is equal to Y over X. Okay, and that is our constant rate of change. Okay, so K is equal to Y over X. In order for this table to be proportional, that means every single K value from each row has to be the exact same. All right, now I'm going to do 10 over 1. Then I have 11 over 2, 13 over 4, and then 14 over 5. Okay, well, I see that my X is increasing, my Y is increasing. Well, 10 over 1 is 10. 11 over 2 is 5.5. 13 over 4 is 3.25. And then 14 over 5 is 2.8. Do we increase at the exact same rate? No, I do not. Okay, so if I'm looking for just proportional relationships, that is not proportional. Okay, now let's take a look at B. Let's create my K column here. Well, I know from number 1 that I have to be a straight line, pass through 0, 0, and I have to have a constant rate of change. Okay, well, look, I'm increasing here and I'm increasing here. Okay, so I know that I want to be a straight line. I see this number right here, or this row right here, 0, 0. That tells me I'm going to be proportional. At the same time, I want to check my K values. Okay, so I don't have to check this one. Now let's look. 6 over 1 is 6. 18 over 3 is 6. 24 over 4 is 6. So B is a constant, or is a proportional relationship, because my K values are all the same and I am 0, 0. All right, let's check C. Okay, well, I can automatically check this right here and tell you that it's not going to be proportional. Because in order to be proportional, I have to be 0, 0. When X is 0, Y has to be 0. So X is 0, but look, Y is 4. Okay. The other way you guys can check this is by actually doing your K. So 8 divided by 1 is 8. 12 divided by 2 is 6. 16 divided by 3. Okay, let's see, 16 divided by 3, that should be 5.3. All three of these numbers are completely different. So not only are we not proportional with this, but our K column is not the same. And then let's check D. So as I'm increasing here, I'm decreasing here. So my K column is 30 over 1 is 30. 15 over 1 is 7.5. 10 over 4 is 2.5. And then 5 over 5 is 1. Well, based on my K column here, I am not a proportional relationship. If you guys have any questions, please let us know.